Welcome to the Explainer. If you're in industrial piping, you already know the stakes. We aren't just moving water to a sink. We're dealing with immense pressures, corrosive fluids, and extreme temperatures. The difference between a high-performance system that lasts decades and a catastrophic failure usually comes down to one thing: choosing the exact right manufacturing standard. You can't just grab any pipe fitting off the shelf. You need precision. So today, we are unpacking a highly specific engineering standard that solves one of the absolute biggest headaches in pipeline design.
Okay, let's look at our roadmap for today. We'll start with the piping space challenge to find ASME B16.28 and compare short versus long radius geometries. Then, we're going to break down forged versus wrought fittings, get into the technical dimensions, and finally, give you practical guidelines for making the right choice.
Section 1. The Piping Space Challenge, when every inch matters.
Picture this for a second. How exactly do you pipe a ship's engine room, or, say, a really tight skid-mounted unit, or a complex manifold? You've got these massive high-pressure pipelines that have to weave through absolutely brutal spatial constraints. In these compact areas, you just don't have the luxury of those sweeping, wide-angled turns. Literally, every single inch matters here. Standard fittings? Yeah, they're way too bulky, and that creates a massive dilemma for engineers and project managers.
Section 2. Defining ASME B16.28, the tight space solver.
So, what exactly are we talking about? ASME B16.28 officially covers wrought steel, butt welding, short radius elbows, and returns. Kind of a mouthful, right? But basically, this standard dictates the exact ratings, overall dimensions, testing requirements, and precise tolerances for these specialized short radius components. Whether it's carbon, alloy, or stainless steel, if it's a wrought fitting making a tight turn via a butt weld, B16.28 is the boss. Oh, and real quick, since it comes up all the time, you might be wondering, what is ASTM or ASME B16.29? People mix these up constantly. Well, B16.29 is strictly for wrought copper drainage fittings, so a totally different world from the high-pressure steel we're looking at today. Scratch the copper. We're focusing on heavy-duty steel.
Now here's a bit of an industry secret for you. B16.28 is actually kind of go standard now. A while back, ASME officially withdrew it as a standalone document and folded it directly into the broader B16.9 standard. But you know, engineers, we can be a bit stubborn. Global stockists and piping engineers still actively write B16.28 on their specs and purchase orders. It's just the perfect industry shorthand to instantly say, hey, I explicitly need this tight 1D geometry.
Section 3. Short versus long radius, 1D versus 1.5D.
To really get B16.28, we've got to stack it up against the classic industry workhorse, ASME B16.9. So, B16.9 gives you a long radius, or 1.5D, and handles massive pipe sizes up to 48 inches. Because of that wider curve, it gives you a nice smooth flow and a lower pressure drop. B16.28, on the other hand, is short radius, or 1D. It only goes up to 24 inches. Because that turn is so abrupt, yeah, you're sacrificing flow efficiency. You're going to get a higher pressure drop. But that sacrifice is exactly what buys you those crucial space savings for tight layouts.
So what does 1D actually mean when you're out in the field? It simply means the center-to-end dimension of the elbow exactly equals the nominal pipe diameter. Think about a 10-inch pipe. The center-to-end distance of that 1D elbow is going to be exactly 10 inches. Boom. Simple. A 1.5D long radius elbow on that same 10-inch pipe, that sweeps out to 15 inches. And those 5 inches you just saved, that can literally make or break your skid-mounted design.
Section 4. Forged versus wrought fittings, B16.11 versus B16.28.
Let's pivot to something that trips up buyers all the time, choosing between forged socket weld fittings and wrought butt weld fittings. Both save space, sure, but they are fundamentally different beasts. B1611 uses small bore socket welds, usually maxing out at a 4-inch bore. These are forged from stuff like ASTM A105 and rely on rigid, defined pressure classes, like Class 9000. But B16.28, it uses wrought materials like ASTM A234, and more importantly, it relies on full penetration butt welds, no internal pockets to worry about, and instead of its own arbitrary pressure class, a B16.28 fitting is designed so its pressure rating perfectly matches the seamless pipe wall thickness it's welded to.
Section 5. Dimensions and tolerances.
All right, let's get into the hard numbers.
When you pull up the standard tables, you're looking at essential variables like the outside diameter, marked D here, and that critical center-to-end dimension, A. The standard lays down some really rigorous tolerances for these, things like out-of-roundness, off-angle, and wall thickness. In fact, to actually hit design requirements, the standard points out that localized areas of these formed fittings might actually need to be thicker than the pipe wall they're intended to be used with.
It's also pretty fascinating to see how this evolved over time to ensure modern safety. It kicked off way back in 1959 as an MSS standard practice because, well, the industry realized B16.9 just wasn't cutting it for short radius needs. It became an official ANSI standard by '64, but check out that 1994 update. That was a massive safety evolution. The computed proof test pressure factor for these fittings was bumped from 80% to a full 100%. Basically, manufacturers had to prove their designs under much stricter mathematical and physical parameters to guarantee they could handle the exact same pressures as the seamless straight pipe, no compromises.
Section 6. Making the right choice. So, how do we apply all this? Here are the clear selection steps every piping engineer needs to follow for their next high-stakes project. Step 1. Assess space versus flow. Yes, B16.28 solves your layout nightmare, but you've got to calculate for the increased turbulence and potential erosion at that tight 1D turn. Step 2. Pick your connection. For small-bore utility lines under 2 inches, a B16.11 socket weld is probably easier. But if you need high-integrity, full-penetration welds for a main process line, you're going with the butt weld of B16.28. And Step 3. Match your materials strictly. If you're using a P91 alloy pipe, you absolutely need a P91 elbow so your mechanical properties and pressure ratings align flawlessly.
Which really leaves us with the ultimate engineering trade-off. Is the physical space you're saving truly worth the extra pressure drop and turbulence your system's going to take on? B16.28 gives you a rock-solid, robust structural solution for those impossibly tight spaces. But at the end of the day, it's on you to weigh that physical layout against your hydraulic flow. So, what's your priority going to be? Thanks for hanging out with us for this explainer on the engineering geometry behind ASME's short radius fittings. We'll see you on the next one.